Now let's move on to chapter 1.2, which is to graph linear equations. Here we are touching upon the second form of linear function, which is the slope-intercept form. This is probably the form that you are more familiar with. In this form, y, which is the dependent variable, is on the left-hand side alone of the equation. And on the right-hand side, it is m multiplied by x, which is the independent variable plus or minus a constant. So here, m is the slope term and b is the y-intercept term. Why is b the y-intercept term? Because when x equals to 0, y equals to b. Right? That means when there is no width, the height of the point that satisfies this line is b. And then how do you calculate the slope? We're using the delta quotient format. So delta means change or difference. And here that is to say changing y over changing x, that is the slope of the line. And here there are several special cases. For a line that is totally horizontal, then for a line like this, totally horizontal, the change in y between 2 points is 0. It's the same height, right? But there is change in x. So if we take that into the calculation of the slope, changing y equals to 0 while there is certain change in x, then the quotient is still 0. That's why the slope of a horizontal line is 0. Then a slope of a vertical line is undefined. Why is that? Because for a vertical line, the width is the same, whereas the height differs. So here we have different y's, but we have the same x no matter what. Then the bottom, the denominator, equals to 0 in this quotient. Therefore, this quotient is undefined. That's why a perfectly vertical line's slope is undefined. Now let's look at the intercepts. The y-intercept is where the line crosses the y-axis. That's when there is no travel in the horizontal axis at all, in which x equals to 0. And here we take that x equal to 0 to solve for y. Y should equal to b, because the first term goes to 0. So that's why b is the intercept term. And that's why this expression is called intercept slope, which is m, intercept term, intercept form. Okay, and the x-intercept, we need to solve for that. Do a little bit solution. That is when y equals to 0. So your right-hand side is 0, and then you're solving x, given m and b. We're going to do one example on that. Okay, so let's look at this example. Find the y-intercept of this one. So this is a standard form for now. The easiest one for us to find the y-intercept is convert this into slope-intercept form, which in that case is y equals to minus 5x plus 9. So we just keep y here, keep 9 here, but move 5x to the right-hand side and change the sign ahead of it. And here, the y-intercept, then that is when x equal to 0 and y equals to 9. And here, to find the x-intercept, we just need to do a little bit of solution. So let's switch to this. So here, y equals to 9x minus 72. And we are to look at the x-intercept. We just draw a line roughly, just to remind us what intercept are we looking for. Say it's something like here, and this is the y-intercept because you haven't traveled at all in horizontal, so x should be 0, and then you're solving for y. That is the y-intercept. Okay, and this one then is the x-intercept because there is no height, so y equals to 0, and here you have to solve for x-intercept. So in this case, we have to solve for x-intercept, and you know that y should be set as 0. So it is 0 equals to 9x minus 72. 9x equals to 72, x equals to 8.